Just a half minute only. Yes, everything is fine now. And once again, good evening, all of the participants. And some of the participants are connecting through the live streaming link so that they can also get some insight about the today's session. So now I am going to share our today's content, which we will discuss during the entire session. Okay, and yes, I hope you can see my desktop. Great. And here, my desktop is visible to all of you, but yeah, yes. So these are the content, dear participant, which we are going to cover today during this session. And yes, so the session will be based on statistical data analysis. Okay, uh, this is the module 4. So here, yes, actually, just 1 minute more. If I can have more, Python day 8. Okay. I make some changes, but don't worry. So here the topic is for the today's session, we have statistical data analysis. Okay, and in the previous sessions also we discuss many things about the statistical data, how we can import, how we can clean the data, and how we can prepare the data set for our statistical analysis. Okay, which will include the visualization, bar graph is there, box plot is there, okay, and KD curve is also there. Okay, so these things we discuss along with the desk by using the describe function. We can have mean, median, first quartile, third quartile, maximum value, minimum value, and many things. All those are very helpful. And in the also today's session, some of the part which we have discussed in the previous can be repeated. Okay, and many things will be new in this file which we are going to discuss here. So the statistical data analysis is a fundamental aspect of the data analysis that involve collecting, processing, interpreting, and presenting data to uncover patterns, trend, and relationship. It provides a structured approach to making data-driven decisions and gaining insight from raw data. And here are some key aspects about statistical data analysis. Okay, so first we can have the data collection and preparation, gathering the structured or whether it is a unstructured data from various sources, just like we can collect the data from by using like survey type. We can have the data from collecting the from the website of from anywhere. Okay, so any kind of data we can have. So first we need to clean, transforming, and handling missing values for accurate analysis. Then after this part is also very important to apply when we can have the descriptive statistics that will include just like mean, median, mode, understanding data, dispersion and variance, standard deviation and range, visualizing data through histogram, box plot, and scatter plot. Okay, so this type of the visualization help us to summarize the data and what type of the data is there and how we can use for our statistical analysis. So these help us to understand to get some insight from the data. Okay, this will help to us to study and to interpret for the statistical analysis, as well as to develop some like of you can say recommending model or prediction model, machine learning models, etc. Then we have the one more special type of inferential statistics. Okay, this will help to drawing conclusion from sample data using probability theory. There are some type of the hypothesis test like t-test, chi-square test, ANOVA test, which we will cover in the coming sessions. And some of these may be in this site, in this file also we have reduced, but all of those tests are not in the single file. So we have to we should have about 3 to 4 sessions to cover all these type of the tests which are essential for the statistical analysis. Okay, confidence intervals, p values for decision making, and these are the most useful regression and correlation analysis. Regression analysis are two types, whether it is a linear or multi-regression model. For the prediction, we can use a predictive analysis and correlation coefficient to measure the association between the variables. Okay. Again, we have this is the just about the overview about the methods and the which we do in the coming sessions. Probability distributions we are using here four type of the probability distributions, understanding normal, binomial, Poisson, exponential distribution. So these applying distribution model in the real world scenario for just like risk assessment and predictions. Okay. Then we have the time series analysis also. This will help us to analyze trend, seasonality, and pattern over time. Okay, so along with the time, how the trend is changes. So time series analysis is very helpful. If we check, we need to check the trend over the time. Also, this will help us for forecasting using ARIMA and exponential smoothing and moving averages. And then we have the multivariate analysis. This is the principal component analysis for dimensionality reduction, clustering technique, and just like key means hierarchical clustering for segmentation. So this type of the methods or the tools are highly useful when we have multivariate analysis is required. And then we have the machine learning integration. Uh, Now we can have the statistical model for predictive analysis combining supervised or unsupervised learning technique with statistical insight. Okay, so whenever we need to think about the machine learning model, so statistical methods play very important role, and all those things which we are required to for statistical analysis, then after we can do or we can apply the machine learning models, and I will try to present several 2 or 3 models which are based on machine learning model. And before that, we can have also some type of statistical analysis part is also required. Then after we can develop some like predictive model, which can be based on the logistic methods or machine learning models, etc. Okay, and then we can have the visualization and reporting. Okay, presenting insight with the chart, graph, dashboard. We can use Tableau or Power BI, business intelligence, creating report for data-driven decision making. Okay, so all these things we can do, and what are the applications which we are discussing? So here, after doing or getting some information about the methods which are useful, and by using the Python, we will do all these type of the methods which are very applicable. But the most important thing, when and what are the applications of this type of the statistical data analysis and data analytic? So by using these methods, we can use for the business intelligence and market research for the for the use of customer behavior, that we can check sales trend. We can use in the sector of healthcare analysis for predicting disease outbreak, patient monitoring. So these are the examples. We can use in the financial risk analysis to get credit scoring, fraud detection. In manufacturing and quality control also we can use for defect analysis, process improvement, and we can use in social media and web analytics for the user engagement and sentiment analysis. Okay, so these are the some applications which we can see and highly useful in the business industry for political analysis, or for the, if you we need to check the social media and web analytic, whether to check the ranking of the websites, etc. So these methods are very, very highly useful. Okay, so now this is the or about the statistical analysis which we can do. Now here is the mainly we are going to start from mean, median, mode. Okay, measure of a central tendency, which will involve mean, median, mode, and everyone, I think, we are all are familiar about mean, median, and mode. But here, what we are doing here, some of the methods how we can get mean, median, and mode. Their methods are there. Okay, and you can see mean can be easily calculated by using summation xi upon n. uh, One more thing I will let you know. We have all type of this inbuilt function, as well as if sometimes we need to write our own method. By following this expression, we can write our own program. And by using the same, we can calculate everything. Okay, sometimes if we have some, you are doing some research on the analytics and you have developed your own method, okay, which is not existed previously. So in that case, you have to write your own method. So that also you can do. And with one or two examples, I will show you how you can calculate all these things, but are quite easy. So not necessarily that if you have inbuilt functions, only those you can use. But you must be familiar how you can write your own method and you can develop your own module also. Okay, so see here for the main, we have the summation xi upon n. Okay, we have xi is one variable and xi are x1, x2, x3, x4. These are the values and n is the length of array. Okay, so this is the method, and by using the same, we will calculate with example. So then we have the median, the middle value when data is arranged in ascending or descending order. Okay. So mode is the most frequently occurring value in the data set. So these are the main central tendencies. And now we have the examples how we can use. So first you can see we required numpy as np. Okay. So by using this library, because we need only the operations on numbers, and this library help us to get these values. Okay, so here we need some data. So data you can have your own, and you can import from outsource, or you have create, or you can have like the data on survey basis. Okay, or some type of data. I let you know that seaborn library provide us some data set which we can use for to apply different type of the methods. Okay, so here we taken this data set. Now we want to calculate the mean value of this data set, which is again very quite simple. Mean is inbuilt function inside numpy. Okay, if we want to use, what you will do, np dot main. Then you will pass this information, which is stored inside the score. Okay, here the entire array is stored inside scores, and we will pass here. So the mean will be calculated, and mean value will be stored here in this side. then this statement we are using to print the value. So when you will execute shift and enter, okay, and you can see the mean is 87.909090 and so on. Suppose that I want to write my own method. Very simple. Okay, just we need to follow uh, this expression. Okay, summation xi upon n. Okay, so see here how we can write, and it is very simple to write. Okay, I am taking new shell. Okay, here I will write first I need sum. I need summation xi. Okay, so I noting it by sm, which will be equal to sum. Okay, sum of all the values which are inside scores. Okay, this will just calculate the sum of all these values which are at this place. Okay, then we need also upon n. The inside the formula we have is upon n. Okay, how many numbers or the values are inside X array? Total number of how many total numbers are there? So this again we can calculate by using n is equal to len, length of the array. Okay, this will return total numbers. Okay, scores. Then the mean will be equal to Sm upon n. Okay, so Sn is the summation xi, as you can see here. Okay, summation xi, and n means n, which is the length of array. Okay, and when you will enter, shift and enter, you can see, okay, we need to print the value also. Main, see, you can see the same value is there. So in this way, you can extend this of the part everything what you need and you want to write your own method. Okay, but the thing is how you will calculate these values which are in this expression. So you have to follow, you need to calculate the numerator values, then you have to calculate the denominator, then you will apply this entire expression, okay, and store the value inside any function, a variable, then print the value. So following this step, you can write any type of the complex formula. Okay, you can write the program for any complex formula and you can easily write in the form of module. You can create your own module and easy to use. Then what are the, okay, so here application of mean. I try to present the applications of everything which we are going to discuss here. So you can easily go through here in the finance and economics. We can calculate the average income of the population, computing average stock prices to analyze market trend, finding the GDP per capita of the country. And if you want to use in the business marketing, analyze average sales revenue over month, determine average customer spending in online store and computing average product rating from users we can use in the education, we can use in healthcare. Okay, everywhere we can use sport analysis, calculating the average goals scored per match in football, analyze the average speed of the athlete in race. So these are the applications of mean. Here, how we can calculate the median. This is also again very simple, and we can have the formula inside and numpy, and by using the same, here is the salaries. Okay, and if you want to calculate the median, and here just you need to apply the formula. Just you need to apply here formula np dot median salaries. Okay, and when you will pass these values inside this function and this will return the median. Okay, so this is the median. But here you can see, yeah, this is the median. These are the applications you can easily go through why we need the median. And for the mode, you have to import this states library, okay, which is from SciPy. Okay, from SciPy, import states. Okay, so this to calculate mode, the method which we are given is inside this library. So from that place, we have to import this module, and only then we can calculate the mode, and which is very quite simple. So here you can see, and this is the purchased values 32353423432, and sometimes we have very large data set. Okay, so just what we do, we will use this states dot mode. Okay, and for purchase and keep dimensions true. And this statement which we are using here will be used to calculate mode value having the highest frequency. So here when you will observe that 3 is repeated many times. Highest frequency of this number is 3. Okay. So when you will shift and enter, mode is 3. Okay. So you can use this for any type of the large data set. But here, just to understand how we can apply this method, we have the functions and we choose small examples for better understanding. And after that, when you can have some idea how you can use, we can have any type of the large data set, and by using easily, we can get this information. Here are the some applications of the mode. Okay, so I will skip this part. Then we have the measure of dispersion. Okay, so how we can, and these matrices show how data is distributed around the central tendency. Okay, so when we have the central value or the central tendency, then about these values, how the data on left side and right side, if you need to check how the data is separate. Okay, this will always help you for more insight study about the data set, and we can easily use all this. So for that, we you can have first is the range. A range we can calculate by using the maximum value minus minimum value from the array, whatever we have the variable. If you need to calculate the variance, okay, measure the average squared deviation from mean, and this is the formula. Sigma square is equal to summation xi minus x bar square upon n. Okay, and if you want to calculate this value, you can do first. You need to check calculate the mean, then you will compute xi minus x bar. It is again very simple. Then if you need the user method, I will provide you. But here I did not write here. Okay. So when I will share this file, I will define here how you can use user function. Okay. So then you can you calculate square, and then you will do sum of all these values, and you will divide by n. Okay. So this will calculate variance. And if you need the standard deviation, and you know this is the square root of variance. Okay, so the square root of variance indicate data separate. And IQR we discussed in the last lecture how we can calculate Q3 minus Q1. Okay, so these are very simple methods, and we must be familiar about all these, what which method is applicable and why these are important. Okay, and here also we have the shape of the distributions. We have the skewness. Okay, I need the marker here. Uh, just 1 minute. So here Just 1 minute. So when you want to check the circuit, the shape of the, you can see first is the positive circuit. Okay, so positive circuit can be have we like when a right circuit. Okay, the data is like in this way. Just 1 minute, I have check the color. Okay, color I'm taking a black. So if the data is like in this side, in this way, when you will visualize in your this type. So this is the right skewed, and if the data is like in this way, when you visualize, so this is like in this way. Okay, so this is the first one, a positive skewed, and this is the negative skewed. And in the case of a positive skewed, the tail is longer on the right. And in the case of negative skewed, the tail is longer on the left side. And if you have zero skewed, okay, so this type of the data is like in this way, like bell shape. Okay, so these are the skewed shape. And if we have the curtices, okay, this is also again important to discuss here. Curtices, we have three types. Okay, one is leptokurtic, a high curtices, heavy tail, more outliers, and cut is greater than 3. Second, we have the platykurtic, low curtices and light tail, fewer outliers, less than 3. And mesokurtic is normal distribution. Okay, so you can have this type of the diagrams. Suppose that this is the normal distribution. Okay, this is the normal distribution. Sorry, you can have this type. This is the normal distribution. And if you have like this shape, okay, so this is the first one leptokurtic. And if you have like in this way, okay, below normal distribution. So this will become platykurtic. So these are the some few examples or the shape by which if you have the visualization, we can easily understand which type of the graph is there. Okay, then we can have, yes, data visualization technique. So these we have already discussed like histogram, box plot, scatter plot, pie chart, bar graph. Okay, and when you are using the box plot, this will show median, quartile, outliers. Histogram displays the frequency distribution of the data. Pie chart or bar graph represent categorical data distribution. And here are the applications where we can use this type of the visualizations. Okay, in business analytics, customer segmentation, sales trend, healthcare, patient demographic, disease prevalence. Then in the finance, we can use for stock price volatility and risk analysis, and quality control. We can use for monitoring manufacturing process deviations. So these are some few applications of all these. Now we can have measure of the variability, range, variance, and standard deviation. Here we will talk about the methods which we are using. Okay, so to calculate range, we have maximum value minus minimum value. So here we are taking the data from, for example, we have this data 15, 20, 25, 30, 35, 40, very quite easy. And if you need the maximum value, to get the range, what we have to do? Maximum value. So NP dot maximum value from data minus NP dot minimum. Okay, you have to subtract the minimum value from the maximum value, and we can get a have range of the data. So by using very simple, just what you need to only the syntax, how we are using to get the max value or the minimum value. And the main thing is we are using NumPy. Okay, just you are familiar about all the functions which we have discussed in the earlier session, and just use np.maximum, np.minimum, and this will automatically return the range of the data. Okay, so when you will execute, and you can have the range which is 25. Okay, then if you want to calculate the variance, okay, so you can have the variance measures the spread deviation of the mean. Higher variance data point are spread out, and lower variance means data point are closely clustered around the mean. And if the large value, then large spread out. Okay, and formula to compute these values, we have sigma square. Okay, and which is summation xi minus mu square upon n. Mu is used for mean of the data, n is the number of observation, xi each data point. Okay, now we are taking the example to use here. You can see data we have is the same. Okay, and we want to calculate here variance. Okay, for variance we have np dot var. This is the inbuilt function inside NumPy. We are not required the high calculation. Just you must be familiar about uh, this inbuilt function and how you can use, and the data which you can have at this place. Directly you will pass this variable for the data set in array. Okay, and this will calculate the variance stored inside variance, and then we are using the print statement. Okay, so you can see we have the variance which is 78.91 and something. And here, if you need to get the standard deviation, okay, so we have.
Hello, sir.
Hello.
Sorry for the disturbance, sir. Here we see that the variance is 72.9.
2 point.
Yeah, 72.9. So in this data, since the highest data is 15 and the minimum is 15 and the highest is 14. So can we say that the variance is high?
Yes, yes.
Okay.
Yeah, yeah.
All right. Okay, sir.
So here, this is the formula to calculate standard deviation. Okay, and this is the formula is here. Okay, but we are using the inbuilt function for standard deviation, which is std. std will calculate standard deviation. Okay, and when you will enter, okay, and the standard deviation is 8.539 and so on. Okay, and similarly, here is the frequency distribution, and types of the frequency distribution we have. First is absolute frequency, the actual count of occurrence for each value or the interval. What are the actual count in the occurrence? Okay, and if we want to calculate relative frequency, in that case, we have the proportion of the observation in each category relative to the total, and this is the formula. Relative frequency will be equal to frequency of a value upon total observation. So by using this method, we can get the relative frequency. And if we need the cumulative frequency, the running total of the frequency, adding each frequency from the previous row, we can get the cumulative frequency. So here we can have better understanding by using the table. Okay, so see, we are taking here very simple data set. Here you can see we have 1, 2, 2 times, 3, 3 times, 4, 4 times. Okay, and frequency of 4 is 4, frequency of 3 is 3, frequency of 2 is 2, and 1 is 1. Okay, so what we are doing, first we are calculating the frequency table. Okay, so here we are using frequency table will be equal to PD dot series from the data. We will count, values will be counted. Okay, just like this value. Okay, then reset the index. So according to that, this will set the all the values. Okay, and here we are printing the value. Okay, so this is the process to calculate frequency table. Then after we have the second one, which is which is relative frequency. That is also we are calculating here, and that will be calculated by frequency table. Okay, from the frequency, and divide it by length of data. Note this one, as we have at the place. Frequency of the value upon total observation. Total observation means the length of the data, how many elements or the values are there. Okay, so this formula is used here to get relative frequency. Okay, then last we have the cumulative frequency. Okay, so the cumulative frequency we are getting by using this function, come sum. So this function will do sum of the previous value. Okay. So here when we will run this these three statement for getting the different values. See, now we observe everything. Okay. So you can see these are the values inside our data set. 1, 2, 3, 4. So 4 is 4 times there in our data set. So the frequency is 4 here. And 3 is 3 times. This is the frequency of 3. And 2 is 2 times. The frequency of 2 is 2. And that of 1 is 1. And if you want to get the relative frequency, what we have to do? We have to divide every with the length of the array, length of the data. So the length of the data we have is 10. You can see here these are 10 values. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are total 10. So the frequency will be divided by 10. So here see, this is the formula, frequency upon length of data. Okay. So these are the values. These are the frequency 4 upon 10, 0 0.4, 3 upon 10, 0 0.3, 2 upon 10, 0 0.2, and 1 upon 10, 0 0.1. So these are the relative frequency. If you want to get the cumulative frequency, and we are using here come sum on frequency. So 4 will be as it is. So since there is no previous value. Okay. So then it will take 3. 3 plus 4 will be 7. And here you can see 7. Then when you will take 2, so this will be 2 plus 3 plus 4. Okay, so sum of these three values, which is 9. And then after for the last, the sum of all these values, which is 10. So by using come sum, you can calculate, this function is used for cumulative sum. Okay, and we all are very familiar about the what is the cumulative frequency. Okay, and how we can calculate manually. But inside Python, we have this function, and we can easily get the cumulative sum. Okay, so corresponding to all this, what we need here, okay, to get absolute frequency, relative frequency, and cumulative frequency. So all these three we have calculated here. Okay, in this table, and also you can see how we can create this table. Okay, see on the left hand side, we are storing the information after computing inside frequency table. Okay, first we store here. We are using values and frequency, then relative frequency, cumulative frequency, and all these values are computed here on the right hand side. Okay, and this frequency is computed at this place. Okay, so by using in this way, we can easily calculate all these values and we can display in one single table. Now we have visualizing frequency distribution. Okay, so how we can visualize? This is again very important because when we have the large data set, so here histogram best for continuous data, and histogram shows the distribution of continuous data using bins. So here we are using the data set from SNS library tips. As you can see here, this is the data set inside which is provided by seaborn library. Okay, so we are not using our data, but from seaborn. This data is provided by seaborn library. So when we visualize data, okay, and when we have heavy data, in that case, always we need seaborn library, as we discussed in the previous lectures. Seaborn very quite easy to visualize large data set. It can easily control everything, and there are some advanced feature as compared to matplotlib, pyplot. Okay, and but sometimes some features that we need to customize for that when we will use seaborn along with we need also matplotlib together so that if we need to customize something we can do with the help of matplotlib. Okay, so both the libraries we have installed we are using here, and this is the data set, and tips will be printed here by using print tips. Since the data will store here, this will visualize the data set, and then after along with the same you can see we are using here plt.figure, figure size 8 by 5. Then here we are using SNS hist plot. Okay, this is the way. There will be several parameters inside tips, but we are taking total bill. And bins 10 caddy true. The caddy curve will be there inside uh, the visualization, and the color we are using sky blue. So these other statement are used to have the title, X label, Y label, and last statement PLT dot show to visualize the data. Okay, so all these things we have discussed in the previous lecture, and I think not required too much explain. So here you can see inside the data set which we are using tips. Okay, so there inside this data set we have these parameters. Total bill is there, tips is there, sex, smoker, day, time, size. These are the size. So we need only the numerical values. Okay, numerical values are here only total bill, tips, and size. Okay, so we can visualize any just like we are taking here total bill only. So for the corresponding total bill, we have this histogram, and histogram is visualized at space. Scroll down. This is the histogram of the total bill. Okay, and at the bottom you can see the bins are there, and the bins we choose here 10. So these are the 10 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and KD curve is also there. Okay, so how the data is distributed? Uh, you can see this is the curve, and this curve is known as we always denote abbreviation which is KDE curve. Okay. And next we have the bar plot. This also we have discussed, but we are using here our this data set which we download here tips. So how you can use for the count plot? SNS.count plot. Okay, x is equal to day, and data we are taking from tips, hue, day, and palette muted, and other are the title, X label, Y label show, and you can easily show here the bar plot. Okay, shift and enter. Yes. So this is the bar plot. You can see, scroll down, and here, yeah, Thursday, Friday, Saturday, and Sunday, day of the weeks. You can see. Pie chart also you can do. You can see this is the very large data set, and from this place we are taking value counts. Okay, we are taking value counts and dot plot pie. Okay, so auto pact we are taking here 1.1 color. These are the color codes are there. These are color code. So for each color we have the color code also. We can use color code. We can give the name of the colors. So it depends upon our choice. Okay, so here the meaning of this will be the data will be presented as percentage. Okay, see, yeah, the above we can represent in the proportional format. Okay, so this is the, you can see Saturday 35.7% and Friday 78% of the entire. Sunday we have 31.1%. Okay, and Thursday 25.4%. This part we have already discussed, choosing the right plot. Okay, the same is there. Then we have the quartile and percentile, and how we can calculate all these. Okay, so quartile Q1, Q2, Q3. Quartile Q1 is the first quartile, which is the 25%. Q2 is the second, equivalent to median, 50 percentile. Okay, and Q3 is third quartile, which is 75. And if you needed to calculate IQR, we have Q3 minus Q1. Okay, and other percentile, if it is required, P25, P50, P75, we can do all these. Okay, P25 will be equal to Q1 and P50 will be equal to median. Okay, and P75 again we have equal to Q3. And if you need the custom, and this is the formula, Pk will be equal to K upon 100 into n plus 1 value. So here we have the quartile calculation, very simple to use. See here, this is the data, and if you need the Q1, what you will do? NP percentile data 25. See very carefully. If you will put at the place 25, that meaning that 25%. If you are using 50, it means 50%. If you are using 75, it means 75%. Okay. And also here in the same, we are calculating the IQR, which is Q3 minus Q1. Okay. And when you need to print, so here we are printing Q1, then median Q2, and then Q3. So all the Q1, Q2, Q3 will be published in the first by using this statement, and interquartile range, which is IQR, will be printed by using this statement. Just shift and enter. Okay, so you can see Q1, Q2, Q3, and if you need to compute percentile calculation, just like 15%, 85%, and you need 65%. So just you will put the value accordingly, and this will automatically return the same as you will put on the left hand side. Okay, so whatever you need the percentile, just you need the np dot percentile function and pass the data and put the what percentile is required. According to that, it will calculate automatically and return the value. And for the print the value, you can use this function f15th percentile, okay, P15 and P85. So the values which are stored on the left side will print here, and you can do, it's again very quite easy. Okay. So now the very interesting part is here, visualizing quartile with the box plot. And in the last lecture, we already discussed about the box plot, but here we have some specific way, and we are importing the data set from seaborn, and we are using, and some more features about the same we will discuss here. Okay, so here the dataset which we are using here is tips, and the libraries are same. Okay, box plot to visualize quartile, you can see SNS dot box plot, x is equal to day, y is equal to total bill, data is equal to tips, q is equal to day, and palette is equal to cool warm. Okay, there are several type of the palette, and according to that you can use. I will provide you the list of all these. Okay, and hue we are using for the day, which is x, you can see. Hue will be always used for x variable, keep in mind. Okay, hue will be always for x variable. And then this is the title and PLT dot show. So in the case of when we are using SNS library, very less statement are required. Control and enter. So this will download the dataset from seaborn, and we have the entire, you can say, box plot is there. Okay, so here you can see we have 4 group on Thursday, Friday, Saturday, and Sunday, and corresponding to all these, we have the box plot, and you can see these are the outliers, the values which you can see circles which are above this horizontal line. These are the outliers. Here is 1, here is 3, here is 2 circles are there, and this value, the horizontal line, this is the maximum value, this is the maximum value, maximum value, and maximum value. Okay, and similarly we can have the minimum value at the bottom. Yeah, this is the minimum value, minimum value, minimum value, and minimum value. So the at this place you can see the box is there. Okay, so the middle line, this is the median. Top line is the quartile 3, and bottom line is the Q1, first quartile. Okay, and similarly for the others also. So this is the box plot which we visualize of our data download from seaborn for tips. Okay, and this is the insight, and we can easily understand from this image. Okay, you can see the maximum value, what are the outliers. Okay, all these are the outliers values which are above 30. This is the maximum value equal to 30. Minimum value is about, you can see, about 8. Okay, and the Q3 is 20, and this is about, you can say, 12. Okay, this is about 17 or 16. So in this way we can easily, when we have the box plot, easily we can study the entire information from our data set. Then after, is there any question? Any question, please? Okay. So here we have the visualizing percentile with the KDE plot. See here, visualizing percentile with the KDE curve. Okay. KDE plot shows percentile position on continuous curve. So here we are plotting the KDE. See, tips we are taking. Okay. Just 1 minute. Yes. Okay, this is the new thing. How you can show everything inside your graph. Okay. See, here we are plotting the KDE, tips football, and fill tube, color sky blue. And then also we want to visualize a percentile. Okay, we can use 25, 50, and 75. Okay, so for percentile, these values, and then PLT, AXV line. Okay, NP percentile, tips football, sorry, total bill, percentile, color red, and line style we are using double hyphen, and label, you can see there is some more statement. Yes, label is percentile. Okay, and then these are the title, legend, show. Okay, so when you will see shift and enter, this is the KDE plot. Okay, KDE plot. This is the curve which you can see here. This is the KDE plot, and also we use here fill. By using the fill function, the inside area between horizontal line and this curve will be in blue, and also the vertical lines which you can see here. These are the first is P25, then we have P50, and then we have P75. Okay, so these are the percentiles which you can see here. Okay, so in this way, the color we are using red, line style we use here, double hyphen and label. By using the label, we have this legend. Okay, P25. Label we are using for the percentage. Okay, percentile. That's why we have these labels. And here also we are using box plot for median and IQR. Just 1 minute. Data visualization with the descriptive static. If you need, we can do. And here key descriptive static to visualize. We are using visualize central tendency, box plot for median, and IQR box plot are ideal for showing median, quartile, and outliers. So what here is inside this visualization? We are using the same libraries, data set we have the same, okay. Box plot figure size we have the same, 8 by 5, and SNS dot box plot x is equal to day, y total bill, data types hue day, cool warm, okay. So this is just the I think visualization. Yes. This has been repeated. Okay, histogram for mean distribution. Okay, here we are using mean line. Yes, this is important. So histogram we are taking here, and SNS dot hist plot tips of total bill, pins 15, KDE true, KDE curve will be there, and color sky blue. And also we are adding here mean line. Okay, by calculating the mean, we will insert here mean line. So sometimes when we have any just like a bar plot, KD curve is there, and we need to insert their median line, mean lines, or just like a first quartile, second quartile, percentile, etc. So we can insert. So these are the examples which we have multiple graph. In the previous lectures, the visualization was simple, but here the visualization is some little bit more complex. Okay, so if sometimes you need to add some more information and you want to combine the graph which are representing the some other information. So by using in this way, we can easily insert multiple graph into the single one. Okay, so here this is the mean value and is calculated here NP dot mean tips total bill, and then we are adding. So you can see here the same function we are using here as we do in the previous one. Okay, mean value, color, line style, and we are using the label for mean value. Okay, 2F is used for float value, and then title, legend, show. These are the same thing. Okay, so here you can see bar plot is there. Okay, and Caddy curve is there, and this red line, this is the mean line. Okay, so where Caddy curve and mean line are intersecting, this point. Okay, this will help you in the coming sessions. Why mean and Caddy curve intersection is required. And sometimes in the normal distribution, binomial distribution, exponential distribution, we need all this type of the multiple graph to study. and sometimes where the curves will intersect. So that point is very, very important for useful. Here is also we have the visualizing variability. Okay, so here we are using the caddy plot for spread and variance. Okay, both we are using. So again, it's quite simple. Caddy plot takes the total bill and fill true, color purple, PLT dot title, X label, etc. We have only the KDE plot for variability. In which manner the data set is varying. Okay, and you can easily go through. You can easily check the graph. Okay, so the data inside our which we have is like varies accordingly. This diagram. Okay, and you can check the shape of vertices. Okay. So with the help of CADI, we can study, and the wider curve indicate higher variability and narrow curve suggest data of is tightly packed around the mean. Okay, but here is very large. If separate higher variability, you can see from this value to up to 60. So here visualizing frequency distribution, we can visualize the frequency distribution also by using bar plot or categorical data. Okay, we have discussed earlier the same thing in the previous lectures. Okay, this is the categorically visualization. Okay, then after we have visualizing outliers. So here what we are doing box plot for outliers, effectively identify outliers. Okay, so here on x equal to we are taking only the total values. Data from tip and color orange. Okay, so when you will execute, yes, see here. So X is taken on, yeah. So this is the minimum value of X, this is the maximum value, and these are the outliers, and the color which we are using orange, this middle line, median, this is the first quartile, and this is the third quartile. Very simple. And inside this example, we have the combining visuals of for comprehensive analysis. Okay, so here combining sometimes what we have, what we are required. You have the one is the histogram, other is a box plot, third is a caddy curve, and one more graph is there. So if you have the four visualization and you want to present all these four or two visualization in the single image at a single place. Okay, so how you can do? See here. So the size we are using 10 by 5. Okay, a histogram, and see here we are using PLT subplot. Okay, 1, 2, 1. What is the meaning of 1, 2, 1? So there will be one row and two columns. And one last one is representing the first image. This one is used for first image. Just like we have the desktop, our laptop, and vertically divided in two parts. So 1 to 1 means the first part, and 1 to 2 means the second part. Okay, so this will be the first image on the left, and we have the SNS history plot. Okay, tips we have total, caddy it true, color is sky blue. And then we have the box plot. Okay, this is the second one. So here we are using 1, 2, 2. Okay, so this 1, 2 and this 1, 2 are common. This one, first image, this two, second image. And inside the second image, we are taking a box plot. Okay, so by using in this way, we can combine these two images at the single space. Okay, so PLT dot tight underscore layout, and then PLT dot show. So this will combine the two and will visualize. Shift and enter. Yes, you can see we have two graphs. Okay, first is the total bill, caddy curve is there, hist is there. Okay, and on the second graph, you can see we have the box plot. Okay, so in this way, you can combine the multiple images. Sometimes here we have the two graphs are there. Sometimes we can have four graphs, and we want to display or visualize at the single place. So in this way, you can customize according to your need. So what you will do if you are using here, if you are using 2 1, 2 1, okay, and here is 2 1. So the first two is rows, and then these are the column. See. So on the top we have the first, and at the bottom we have second. And if you can have four, if you have four images are there. So what I am doing, I am copying all these. Copy and paste here. So I have four images. Okay. So what I do now, the dimension is 2 by 2. First I have to change this one, 2 by 2. This is the first image, this is the second image. Okay. And then after this is 2, and here is 3. This is 2. The matrix is 2 by 2. And this is the fourth image. Shift and enter. See. So 2 are on the top and 2 are below. Okay. First, second, third, fourth. In this way. First, second, third, fourth. So in this way, you can generate multiple images according to your need, your use. Got it? But these are only I have to place the original was invalid. Control Z. Now it is fine. Yes. Okay. And this is the summary of the static with the pandas. So these are the some function describe, mean, median, mode, maximum value, minimum value. All these we have used in the previous, and also here we use these functions. Okay. So half content I am able to present here, but not the entire. You can use here. So if you have any question, please you can ask from me. I will share with this file with you, and there are some more content here, which you can go through all these. Okay, but now the time is over. All these things we have discussed, all the functions, a probability distribution, and these are new one. Okay, so this part, up to this part, this is the section. This is the section. 4.2 will start from this place. Okay, so from this above all the part we have already discussed, and if you have any question for the today's session, you can ask for me. Otherwise, we will close the today's session. Yes, please. Any question? Is there any question? Okay, no problem. I think the content which we are covered today are simple, but just we need to understand the syntax and how the multiple graph we can insert whenever it is required for our purpose, how we can present our visualized images in matrix format. Okay, in 1:2 ratio or 2:1 ratio or 2:2 matrix form, etc. So according to our need, how multiple graphs are there which we want to visualize in the single image, we can manipulate all these things by using in this way. I will share all the content which we discuss here, and the file will be there in your WhatsApp group. Some partially content, just like a probability distributions, there is normal distribution, binomial distribution, exponential distribution, okay, binomial distribution. So all these are there, and you must try all these functions. Very quite simple to use. But one more thing, why we are using. Actually, the thing is to visualize by using the command is one thing. Secondly, to understand the which we have visualized, what we get the information after visualizing the data set. That is very important to implement in our study. So this can be possible only if when we are doing our real data and we are doing some study, okay, and when we will apply. Okay, so the basic concept about all these we have provided in the content, and how we can get the insight, and along with the when we are using the data set, we try to provide interpretation of the data set. So interpretation, how we can interpret after visualize our data set, this part is very, very important. Okay, and we try to interpret every image after just like probability distribution, etc., whatever we have in the coming session. So I hope this content will help you. Okay, so for the today, thank you, and time is 9:20. Thank you to all to listen this lecture, and tomorrow we will start at the same time, 7 p.m. Okay, since 1 hour is not enough for us, so we need 2 hours to present the entire content. Tomorrow we will start the session sharply at 7 p.m. Thank you to all and good night. If any question, you can feel free to ask from me. And the file will be available in your WhatsApp group. Okay. Good night. Good night, everyone. Good night.